So let's begin with going through chapters 2 and 3 in naked statistics. So, what are descriptive statistics for? A descriptive statistic reduces a large, unwieldy data set into a few meaningful numbers. So, Whelan used the framing example of Derek Jeter. So, instead of describing every single one of Derek Jeter's 9,868 at bats, we just say that his career batting average was 313 or 31.3%. So this is powerful. It's very easy to communicate and very easy to compare between players. But it's also dangerous. It necessarily throws away a lot of information. It removes a lot of details about Derek Jeter's career. Did he have a single great year or did he have a lot of good years? How many home runs did he have? How many strikeouts? How many RBIs? I'm not a baseball fan, even though I'm from the home of the Little League World Series. So I don't know any other baseball stats. But relying on just the batting average to compare players can obscure a lot of information about their career. So what I want to emphasize is that every descriptive statistic is a simplification. It's really, really useful, but it's a simplification. So the question shouldn't be, is this statistic true? Hopefully, when we're reading something, we can trust the source that we know is true. But when you look at some descriptive statistics and summary statistics, think, what does this statistic hide? And this is going to set up our framing for chapter 3. So something that students often mix up is mean versus median. And this can be tricky for anyone working with statistics. No matter how long you've worked with it before, it's easy to slip. So the mean or the average is the sum of observations divided by the count. The median is simply the middle value when you sort the data. Or if the number is even, it's the average of those two middle values. So Whelan uses the bar stool example. So there are 10 people earning 35,000 a year sitting in a bar. And so here the mean is 35,000. Bill Gates, with an income of like $1 billion, sits down at the bar. The mean then jumps to $91 million, but the median stays at $35,000. Because the median only cares about the order or the position, not the overall magnitude. So it's easy to conceptually think of the median as just a weaker version of the mean. But you want to think that slightly differently. So the mean answers, what if we split this total evenly? While the median answers, what does a typical member of this group look like? These are different questions, and the presence of outliers only distorts the answer to the first one. So if there are no outliers, then the mean and the median are going to be pretty much the same. And later on, we'll look at different distributions of data where the mean and the mean are practically the same. But in some cases, when there are outliers, the it really distorts the answer, and the mean and the median will be very, very different. So Whelan uses the mean versus median to make two opposite points in different examples. It can be tempting to walk away thinking that the median is more honest and the mean is more deceptive. But that's not the lesson he wants you to take away from it. That's not the lesson that I want you to take away from it. The lesson is that the right statistic depends on where the outliers are and what we care about. So he gave an example in chapter 3 about the Bush tax cuts. The mean tax cut was $1,083, which looks pretty generous. But the median tax cut was under $100. So most people didn't get that much. I mean, an extra $100 is nice, but nothing like $1,000. So you had a few huge cuts, like a small portion of the population receiving large tax cuts that increased the mean and made it look more generous than it really was. So here the median is a more honest summary of the typical taxpayer's experience. On the other hand, look at drug survival. So a drug's median survival benefit of 2 weeks might look unimpressive. But if 30 to 40% of the patients were effectively cured by this drug, the median completely hides that outcome because it doesn't weigh how far above the middle those patients are. Here, the median is misleading, and the outliers are the whole story. So to paraphrase Whelan's summary, that he gives for his rule for the mean versus the median. is the mean versus median question comes down to whether the outliers in a distribution distort the message or if they are the message. So in this case, there's no formula to tell you which one to use. It's your own personal judgment. And in most cases, a complete analysis is going to report both the mean or the median, or give enough information if you give the mean or the median to show that you don't have to worry about the other one. Let's move on to percentiles and the normal distribution. So these all describe an observation's position relative to the rest of the distribution. Instead of its like raw value or its absolute value. So the percentile, this is an observation's rank out of 100. So the 83rd percentile is better than 83% of the group. The quartile splits the distribution into 4 equal parts, so that's 25% each. A decile will split the distribution into 10 equal parts, or 10% each. So think about absolute versus relative. An absolute figure, say you scored 43 out of 60, has a meaning on its own. A relative figure, the 83rd percentile, only has a meaning in comparison to the reference group. So most standardized test scores are only meaningful in the relative or the percentile form. All right, let's move on to the percent change versus percentage points. This is a very important distinction and something that people mess up all the time. In the first drafts of my papers, I often have to go through specifically looking for where I messed up these two things. But let's think about the formula for percent change. It's the new figure, the new number minus the original number divided by the original number. It's easy to fall in the trap with the $100 dress. So let's say there's a $100 dress. The price is marked down by 25%, goes from 100% to 75%, or $100, excuse me, to $75. Let's say it's then marked back up 25%. It's tempting to say that the price is going to go back to 100. You went down by 25% and up by 25%. But the second 25% is calculated on the new lower base, on $75, not the original $100. So moving for 25% of $75 is going to be less than $25. So instead of going back up to 100, you'll go up to $93.75. So a separate and commonly confused idea is the percentage point change versus the percentage change in a rate. So an example we saw here was the Illinois income tax. So it rose from 3% to 5% of income. So as a percentage point change, going 5 minus 3 is 2 percentage points. But as a percentage change, it was a 67% increase. So 5 minus 3 is 2, then divided by 3 is 0.66 or 67%. Now both the percent change and the percentage point change are correct, but they're answering different questions. And typically which one gets quoted or talked about in, say, a newspaper or some headline or tweet you see is going to be whichever makes the change look big or small, which is what depending on what the person saying it wants. So Whelan frames it as a Democrat versus Republican thing. A Republican may say it goes up a 67% increase. They focus on percentage change. They want it to seem large. Democrats wanting to downplay it will say it's only a 2 percentage point increase. Neither is incorrect, but they both have their own particular motivation for which one they choose. Now let's think about precision versus accuracy. Precision is how exact a figure is. So 1.265 miles. Accuracy is whether the figure is actually correct. A very precise number can still be completely wrong. So Whelan talked about his own golf range finder, gave him a very precise distance of 147.2. However, it was set to meters, not yards. So this precision without accuracy, it didn't actually tell him how far away he was from the green because of the different units. It made his golf game worse, not better. So it's important to think about the units we want to use for our analysis. That's why two true statistics can contradict each other. So the unit of analysis is what is being counted or what is being compared. So schools versus students, counties versus people versus states. So two politicians might get up arguing about schools. One may say 60% of our schools had lower test scores. Here the unit equals schools. The other may say 80% of our students had higher test scores. Here the unit is students. Both of these things can be true at the same time. If, for instance, the improving students are concentrated in a few very large schools. In this case, neither politician is lying. They're counting different things, focusing on different things to tell the story that they want to tell. We can use the same logic to think about the globalization and inequality debate in the chapter. So richer countries grew faster. Here the unit is countries versus global inequality fell for people. Here the unit is people. Both of these can be defensible based on what question we're trying to answer. So when you're thinking about the variables that you use in an analysis, think especially when you're thinking over time, nominal versus real figures are really important. So nominal figures are adjusted for inflation, are not adjusted for inflation. Real figures are adjusted for inflation. So when you're comparing, say, dollar amounts across years without adjusting for inflation, this is Whelan's apples and oranges problem. It's the same thing as comparing prices in two different currencies without an exchange rate. So by nominal or unadjusted dollars, Avatar and Shrek 2 rank among the highest grossing films ever. But when you adjust these for inflation, so you use real dollars, Gone with the Wind from 1939 is the #1 movie of all time, and Avatar drops to number 14. This is a vivid, memorable illustration of just how extreme the difference can be, especially because we're looking at a very old movie from 1939 before a lot of inflation occurred. If you're working at something over the short term, you may not notice a real difference if you're using nominal dollars instead of real dollars. But when you look over a long period of time, like stretching back to the 1930s, you can see a really large difference, and failing to adjust for inflation can throw off your entire analysis. So for indices, there is a lot of power in computing these. It makes it very easy to compare a lot of details about multiple observations, but there is a serious danger. So any index like the NFL passer rating, the US News College rankings, the Human Development Index, these combine multiple descriptive statistics into a single number to look at. This helps you compare otherwise incomparable things. You can rank them, you can use them in a statistical analysis. There are some great advantages to this. So you can have a real complex multidimensional comparison with just one simple number. The Economic Freedom of the World Index combines a whole lot of different types of government regulations and rule of law, a whole bunch of different related measures, boils them down to just one number, which is great if you're trying to use an analysis, you're trying to compare different countries. But there's a real disadvantage with this. And the disadvantage is that the ranking is only as good as the components that are included and how those different components are weighted. And unfortunately, both of those choices are judgment calls. They're not objective facts. So you have to hope that the person making the index is really, really trustworthy and really smart. So there's an example from Malcolm Gladwell about car and driver. If you reweighted the same underlying data towards styling favors, um, if you reweight, oh, excuse me, my notes here are a mess. Okay, so if you reweight the underlying data towards styling, that's going to favor the Lotus. If you reweight towards value, it's going to favor the Corvette. The original formula, as used, favored the Porsche. Nothing about the cars here changed, only the weights we use for the different components changed. Okay. So US News College rankings are often criticized because Inputs like academic reputation, or I put air quotes, academic reputation, are subjective survey data. And the rankings reward inputs, so selectivity and spending, rather than actual outcomes. So, like the learning that the students have or the job placements that they get. Now, there's an idea that you can't manage what you can't measure, but there's an opposite of thing that happens once you put that into practice. Once people are evaluated on a specific measure or a statistic, they may optimize that statistic instead of the underlying goal. So a while back, Houston schools, their dropout rates were minimized by reclassifying dropouts as being transferred or moved away, rather than keeping the students in school. So they were able to reduce the dropout rate. Good. They hit a specific target that was being measured, but it wasn't through the improvement of their performance level.